Alright, today we're going to talk about the other objects found in our solar system. We talked about the inner four planets, the outer four planets, but there are a lot of other objects in our solar system besides the 8 planets. First off, between Mars and Jupiter is an area that is occupied by the asteroid belt. Now, asteroids are rocky fragments left over from formation of the solar system about 4.6 billion years ago. Most of these fragments of ancient space rubble, sometimes referred to by scientists as minor planets, can be found orbiting the Sun in a belt between Mars and Jupiter. This region in our solar system, called the asteroid belt or main belt, probably contains millions of asteroids ranging widely in size from Ceres, which at 940 kilometers diameter is about 1/4 of the diameter of our moon, to bodies that are less than 1 kilometer across. There are more than 90,000 numbered asteroids. And there are a lot more than that just because smaller objects reflect less light and they're harder to find with telescopes. So here you see a picture where we have Mars's orbit right here, fourth planet, and then we see Jupiter out here, big gas giant, and then we see this zone out here where the asteroids lie. Now we also have comets in our solar system. Comets are cosmic snowballs of frozen gases, rock, and dust roughly the size of a small town. When a comet's orbit brings it close to the sun, it heats up and spews dust and gases into a giant glowing head larger than most planets. The dust and gases form a tail that stretches away from the sun for millions of kilometers. Here in this picture, if you look closely, you can see almost 2 tails. Oftentimes a comet will produce 2 distinct tails, so maybe one right here and one right here. One will be in the path that it's taken, so it'll leave debris behind. The other one will be showing the direction that material is being blown away by the solar wind. So we'll have one tail caused by solar wind, one caused by material that leaves behind. Now when we have meteor showers, those are oftentimes because we're crossing the path of a comet. And so we are passing the path of one of these comets, left behind all these pieces of rock and dust, and they enter our atmosphere and cause meteor showers. We also have dwarf planets. Now, dwarf planets are planets that have not cleared their own orbit or have an irregular orbit, such as Pluto, Ceres, and a lot of the Kuiper Belt objects. Now, this is a picture of the largest known Kuiper Belt objects, all classified as dwarf planets. Pluto, because of its size compared to its moon, could almost be considered like a dual planet, but all of these are called dwarf planets. They do not clear their orbits, which means that they have their own distinct orbit around the sun. With Pluto, because it kind of orbits with its moon, it doesn't clear its orbit. Plus, Pluto crosses Neptune's orbit, so sometimes Pluto is closer to the sun than Neptune. Now, this picture here, which was produced shortly after the decision of what is a planet, what isn't a planet, which happened in either 2007 or 2006 in the late summer. You can see that we have our 8 planets up here, and then we have some dwarf planets. Ceres, which is in the asteroid belt, Pluto, 2003 UB, which used to be called Xena. And we actually have a lot more we could classify as dwarf planets, but most of these dwarf planets are very far away from the sun. They're very small. They're hard to find. We don't even have a good picture of Pluto because of how far away it is from the sun. So as we have some satellites that are finding their way out into the Kuiper Belt, they will take pictures and send us information back about these dwarf planets. Now, the Oort Cloud. In 1950, Dutch astronomer Jan Oort proposed that certain comets come from a vast, extremely distant spherical shell of icy bodies surrounding the solar system. This giant swarm of objects, now named the Oort Cloud, occupying space at a distance between 5,000 and 100,000 astronomical units. And remember that 1 AU is the mean distance of Earth from the Sun. The outer extent of the Oort Cloud is considered to be the edge of our solar system, where the Sun's physical and gravitational influence ends. So the Oort Cloud is kind of the boundary at the edge of our solar system, where there's a tremendous number of materials that find their way out there that were left over formation of the solar system. Now, the Oort Cloud probably contains 0.1 to 2 trillion icy bodies in solar orbit. Occasionally, giant molecular clouds, stars pass nearby, or tidal interactions with Milky Way's disk disturb the orbit of one of these bodies in the outer region of the Oort Cloud, causing the object to streak into the inner solar system as a so-called long-period comet. These comets have very large eccentric orbits that have been observed in the inner solar system only once. So they only take one pass in, and they have a very regular orbit, and once they leave, they sometimes never come back. Now, in contrast, we have short period comets that take less than 200 years to orbit the Sun. They travel along the plane in which most of the planets orbit. They are presumed to come from a disc-shaped region beyond Neptune called the Kuiper Belt, named for astronomer Gerard Kuiper. The objects in the Oort Cloud and the Kuiper Belt are presumed to be remnants from formation of the solar system about 4.6 billion years ago. The Kuiper Belt extends from about 30 to 55 AU, is probably populated with hundreds of thousands of icy bodies larger than 100 kilometers or 62 miles across, an estimated trillion or more comets. So when we talk about Hale-Bopp or any of these other comets that we see like every 100 years, every 50 years, these are short period comets and they exist on the Kuiper Belt. So they have a path that takes them in close to the Sun and sends them back out, and they repeat this over and over again. The long period comets, which come from the Oort Cloud, they have only really one pass before they go so far out of the solar system they are no longer pulled in by the Sun. Now, in 92, astronomers detected a faint speck of light from an object about 42 AU from the Sun. First time a Kuiper Belt object, or KBO, had been sighted. More than 1,300 KBOs have been identified since 92, sometimes called Edgeworth-Kuiper Belt objects, acknowledging another astronomer who also is credited with the idea. They are sometimes called transneptunian objects, or TNOs, because they are beyond Neptune. Because KBOs are so distant, their sizes are difficult to measure. The calculated diameter of KBO depends on assumptions about how brightness relates to size. With infrared observations by the Spitzer Space Telescope, most of the largest KBOs have known sizes. Again, we have not sent any type of man-made object out to this area yet, so we have not been able to get accurate measurements. And that is something down the road we're hoping with some future satellites to be able to send them out there and actually measure things.